Welcome back, everybody, to the FreeBSD Learning and Education bonanza that we're having here. Remember, there could be no Unix without you. So, today we're going to be talking about drivers. And a driver is a piece of code that functions as a translation between either hardware, which could be physical or virtual, or certain other tools and the system itself. So without a driver, your computer typically cannot interact with an object. So you have drivers for your keyboard, you have drivers for your mouse, you have drivers for your webcam, for your microphone, or just about anything you can think of that will typically have a driver. Now, FreeBSD, Unix, Linux, Windows, Macintosh, every single one of these devices have to have a driver, which is why sometimes you will discover that a piece of hardware that you want to be able to use, sometimes it even says right on the box, doesn't work with Linux or doesn't work with Macintosh, or it'll state only works with Windows and only works with Mac. And typically that comes from the fact that the drivers that were created and distributed by the manufacturer were only created for one system. And if somebody doesn't go in and translate those drivers, then that object's not going to work. Case in point, I have a combination microphone with video camera, just a fantastic piece of hardware. Used to work under Linux, and then there was an update to the kernel, and then that piece of hardware stopped working, and you just simply can't use it. I've done a ton of troubleshooting. I have tried to work with the manufacturer and they will not work with me. I have even started the process of trying to use a tool like USB cap in order to create a PCAP file of the USB file itself so that I could view it inside of Wireshark. I've gone quite to the extreme on trying to get this piece of hardware to work, and I just don't have time. I have a family, I have multiple jobs, I'm doing the YouTube thing. There's just too much stuff going on in my life for me to sit around and try to fix that piece of hardware. So, with that said, I'm going to teach you a little bit about drivers. What we're going to do is we're going to create a skeleton driver. This is actually a file that is provided by the folks at FreeBSD within their handbook. You can create this yourself. We're going to load it, we're going to unload it, and we're going to demonstrate how to see which drivers are in use. There is an actual command that you can use that's sudo kldstat. We hit enter, and now you can see there's the kernel, dfs.co, cryptodev.co, intpm.co, smbus.co, virtio_console.co, uhid.co, usbhid.co, hidbus.co, wmt.co, ip.fw.co, and then macntpd.co. And if you remember a few videos back, we actually set up the firewall. We did that under IPFW, and that's how you end up with that IPFW kernel module running. So one of the cool things about the FreeBSD system is all the drivers can be run as kernel modules instead of actually directly within the kernel. You don't have to bake them in. So if one of them crashes, theoretically, you don't have to restart the entire computer. You just lose access to that device until you either repair it, fix it, reboot it, pull it out of the USB port and put it back in, or whatever it is that you need to do. In theory, it is also increases security, because if you bake a driver directly into the kernel, potentially if you have a vulnerability within the code base, then somebody could execute an attack on the kernel, which is exactly what you do not want to have happen, right? So, with that said, there's a handful of things that we will have to do. We are going to need not a significant amount of code, but we're going to need a little bit of code. And then we're also going to need to make some changes to our kernel source that is actually loaded inside the system. And I'm going to show you how to do all of that. So the first thing that we're going to do is we're actually going to go in and we're going to make changes to the kernel source. So if we were using the main branch, which is what we're using right now, theoretically that's 14.0 right now. We're on 13.1. Obviously, they're working on the system right now, and they're trying to build things and do all the stuff that they want to do. So we're going to go to sudo user source, We'll type ls, we see everything here. If I tried to do git checkout and all of the work, it's not going to work. Okay, so what I did was I took a snapshot before I started here. I'm going to show you how to do this a little bit messy, just on account of A, I don't have a lot of time, and then B, there's going to be other people who are going to be following along with this, and I just need this to work. This is not the correct way to do this by any stretch of the imagination if we were in a professional setting. But this is an educational setting, so I'm okay with this. We're going to type sudo git checkout. Actually, we don't want to do checkout. We want to do sudo git switch F for force, and then we need releng /13.1, and we're going to hit enter. It's going to take a few seconds. And if you're at this point right now and you're asking yourself, okay, how did he know to go in here and do releng /13.1? I don't know. How did we switch to this new branch? Uname switch A, and you will see 13.1. If we come to GitHub, where the FreeBSD actual source tree is, we can scroll down here, and you will find releng 13.1. So we're at 13.1, which is the latest release. We needed release 13.1. I switched to that. That's how we end up here. That's how I do that switch. I'm going to cd tilde / pwd, Papa Whiskey Delta, hit enter. We see that we're in home Aaron J. Fantastic. I'm going to make a directory, and I'm going to call this skeleton_driver. Hit enter, and I'm going to cd into here. Now, I have, and you'll be able to see this in the description, I have 2 links that will give you the files that you need here. The first one is going to be skeleton.co. I want to open this as raw, and I'm just going to use, you know what? I'm going to install sudo package install wget. See if that makes my life easier, right? I'm just going to pull it down. So what is wget, you might ask? Wget is a tool that functions very similar to curl in that I can take wget, give it a URL, hit enter, press ls, and now I have skeleton.co. So I can download bits and pieces of web pages and things like that if I need them. So we have skeleton.co. The next piece that we want is this piece. I'm going to open this up. This is a make file. I'm going to wget this, hit enter, and then the next thing I'm going to do is I'm going to type make and hit enter. And you'll see here some stuff just happened. What we have done is we actually compiled the code. So if I type in vim makefile and take a look in here, you'll see our source is skeleton.co, kmod equals skeleton, and then we're including a file which is related to our kernel, which references user source. Okay, and if you haven't taken any programming courses or anything like that, that's totally okay. Again, the whole purpose of this is not to introduce you to computer programming. It's just to get you a little bit more knowledgeable about the operating system and some of the stuff that goes into it. So this is KLD Skeleton. This was inspired by Andrew Ritter's Demon News article. We see a bunch of includes here. H, anything that ends with an H, those are header files. So those are used for referencing stuff that you might need. Types, system name, error, params, modules, and kernel. And then we can see there is a static int, kldload. It has a switch, and what it does is it sees, hey, have I been loaded? And if I have been loaded, then I'm going to produce some text that says skeleton KLD loaded. So we'll see that here in a second. But we have taken all of the code here within this module, and we have turned it into a kernel module. And if I head back on over here, I should, in theory, be able to type sudo kldload -v skeleton.c, hit enter. Oh, skeleton.ko, hit enter. Skeleton.ko is not in the module path. Hold on. Got it. Attention to detail. I forgot to put the period /. So sudo kld, and then we want to do load -v with the period .skeleton.ko. Hit it. Skeleton kld loaded skeleton.ko ID3, and then we can prove this by using kldstat, sudo kldstat. Hit enter, and we can now see it right down here, skeleton.ko. So what does it do? Nothing. It just says skeleton kld loaded. That's it. Doesn't do anything, and if we were to unload it, sudo kld unload skeleton.ko, it will tell us skeleton kld unloaded. That's it. That's all it does. It's just completely designed to get you into the thought process of how do I create a module? How do I compile it? How do I add it to the kernel via module? And then how do I unload it? And that's it. That's all we're doing. Okay. It's not super complicated, and there's not a lot of stuff here. And I don't expect my first year, second year students to really be looking at this and thinking to themselves, okay, now I have all the magical ingredients that I need to start doing module creation or module hacking or anything like that. The whole purpose here is just to familiarize yourself with some of the terminology, show you how some of these items work, and introduce you to the module concept, but really nothing beyond that. Now, in the future, we'll go over some items like, again, using a tool that functions very similar to Wireshark in order to create a PCAP file related to USB tools. And then when you capture all of that data, you can actually use that to reverse engineer a piece of hardware. And then from there, you could potentially create a driver so that a piece of hardware that typically would not work for an operating system then could work. In addition to that, another very cool thing that you can do is sometimes if you find drivers that work under Linux but they don't have an equivalency for FreeBSD, you can actually translate those Linux drivers into a FreeBSD driver and vice versa. But that's much rarer, and I highly doubt that you're going to find hardware that only works under FreeBSD and not under Linux. But we're not going to go into that part. So with that said, thank you for joining me. I had a tremendous amount of fun working with you all tonight. We got to see me make some mistakes here, but then we recovered. And I want to leave that in here, not for the sake of being lazy, but for the sake of I want you to see that even having done this for years and years and years, sometimes I'll fat finger something. I will do the command wrong. I will miss a piece. I will not have that piece of attention to detail that we actually needed. And that's okay. You make mistakes and then you recover and then you move on. And you're going to have those moments where you're going to be super frustrated with your computer and you're going to wonder why stuff doesn't work or why something isn't doing what you expect it to do. And then after a few minutes of playing with it, you're going to have that aha moment, and that's great. And here within this whole driver creation piece, this is where we're going to have that. And people are going to run into errors. They're going to see that something doesn't work, and you're going to have to go back and really take a look at the commands and see what you did wrong. So with that said, thank you very much for joining me. I really appreciate it. And just remember, without you, there would be no Unix.